Okay, before we go any further, we're going to talk about this idea of what a conjugate is. Let's say if I have 2x plus 4. The conjugate of 2x plus 4 is 2x minus 4. Basically, what a conjugate is the numbers stay the same, the 2x and the 4 stay the same, but the mathematical operation changes. So instead of 2x plus 4, it would be 2x minus 4. Now typically when I multiply two binomials, think about how many terms we end up getting. We usually end up getting 3 terms, a first term, a middle term, and a last term. But watch what happens when I multiply a binomial times its conjugate. So when I multiply these together, 2x times 2x is 4x squared. 2x times 4 is 8x. Negative 4 times 2x is negative 8x. And negative 4 times 4 is negative 16. So like I said a minute ago, when we multiply two binomials, we usually end up with 3 terms, a first, middle, and last term. Well, this one we have a first term, 4x squared. Our middle term, 8x minus 8x, is 0. It's nothing. They cancel each other out. So I'm left with 4x squared minus 16. So in other words, anytime we multiply a number by its conjugate, all we care about are multiplying the first 2 terms and the last 2 terms, and we get our answer. But that only works, again, when we're dealing with conjugates. So if I had, let's say if I had this problem, 5x minus 2, the conjugate of that is going to be 5x plus 2. So I know if I'm multiplying this number by its conjugate, all I care about are multiplying the first 2 terms and the last 2 terms. So I get 25x squared, and negative 2 times 2 is negative 4. So my answer would be 25x squared minus 4. But we're not dealing with x's today. We're dealing with complex numbers. So I could change this into what's called a complex conjugate by changing these x's into i's. So remember, a complex number is 5i minus 2, or negative 2 plus 5i would be another way to look at it. And so for this one, if I had 5i minus 2, my conjugate would be 5i plus 2. So when I multiply those together, I get 25i squared minus 4. But remember, I squared is the same as negative 1. So this would actually be negative 25 minus 4. So our answer would be negative 29. So as it is, when we multiply just a regular binomial by its conjugate, something unique happens. We end up with, instead of 3 terms, we end up with 2 terms. Something even more interesting happens when we multiply a complex number by its conjugate. We get a single number. There's no more i's left over. It's just negative 29. So let's go back to our notes here to see how we use this. So again, the complex conjugate, if I have a plus something in the form of a plus bi, the conjugate of that is going to be a minus bi. So the reason why we use this is if we're dividing 2 complex numbers, we're going to multiply both numerator and denominator by the conjugate of whatever's in the denominator. Because our whole purpose of this is then we get a real number in the denominator. Because fractions, guys, fractions are unique. There's some rules dealing with fractions. We can never leave a decimal in a fraction. That's not proper. It's not proper to have 0.2 over 8. Okay, we got to simplify that. Another thing about fractions, you can't have a fraction within a fraction. You can't have 1/2 over 4 or 7 over 3/2. We have to simplify that. Another rule is we can't have the square root in the denominator of a fraction. I could have square root of 3 over 2, but if I had 2 divided by the square root of 3, I would want to simplify it. Same thing with imaginary numbers. I can't have an imaginary number in the denominator. That's all there is to it. You can never leave an imaginary number in the denominator. So what this paragraph is saying is that in order to get rid of the imaginary number from the denominator, we multiply by the complex conjugate, meaning the conjugate of our denominator, which would be 3 plus 2i. The whole purpose in doing that now is to get rid of the i's from the denominator. Because if I multiply these, let's do these first two, the 3 minus 2i over here, times 3 plus 2i. We just talked about the fact that when I multiply a number by its conjugate, all we care about is the first terms and the last term. So 3 times 3 is 9. And negative 2i times 2i is minus 4i squared. Well, I squared is negative 1, so this becomes 9 negative, 9, negative 4 times negative 1 becomes plus 4. So I have 9 plus 4 is 13. So my denominator here is going to be 13. Now I need to figure out what goes on top. What goes on top, the way we're going to get that is just like what we're doing in these examples right up above here. We're going to multiply the two binomials, or the two complex numbers together. And I can use my window method for that. So if I multiply these together, 3 times 3 is 9, 3 times 6 is 18, so I have 18i. In the bottom row, 2i times 3 is 6i, and 2i times 6i would be 12i squared. Remember, I squared is negative 1, so this would be the same as negative 12 here. So now when I combine like terms, 9 plus negative 12, or 9 minus 12, is negative 3. And 18i plus 6i would be 24i. So my answer would be negative 3 plus 24i all over 13. Well, we want to write this as a fraction, because we want to put this in a plus bi form. Well, right now this is all written as one single fraction, so I want to break this up into two smaller ones. So my answer would be negative 3 over 13 plus 24i over 13. Because now what I do is I look to see, is there anything that I can reduce here? 3 13ths can't reduce, 24 13ths can't reduce, so my answer remains negative 3 over 13 over 20, or plus 24i over 13. Okay, why don't you guys take a minute now and work on this last example. So I want you to pause the video and hit play when you're ready to check your answer. Okay, so with this one, what you should have done is multiply the top and bottom by the conjugate, which is 3 minus 4i. When you do that, in the denominator here we get, I'll do that over here, we get 3 plus 4i times 3 minus 4i. Gives me 9 minus 16i squared, which is the same as 9 plus 16, which is 25. In the numerator, we would take 5 minus 2i times 3 minus 4i. Make sure you get your negatives in there, or you're going to get the wrong answer. 3 times 5 is 15. 3 times negative 2i is negative 6i. Negative 4i times 5 is negative 20i. And negative 4i times negative 2i is 8i squared. Simplify this. 8i squared would be negative 8, because I squared is negative 1 times 8 would be negative 8. 15 minus 8 is 7. Negative 20i minus 6i is minus 26i. Break this up into two fractions, and I get 7 over 25 minus 26i over 25. And we have our answer in a plus bi form. So that's it. So again, you want to make sure that you remember that I squared is the same as negative 1. You want to make sure that you remember that the conjugate, in order to, if we have a fraction, we can't leave an imaginary in the denominator, so we multiply the top and the bottom by the conjugate of the denominator. And hopefully, after watching this video, you have a better idea how to work with complex numbers. So good luck on that assignment.